Welcome to this episode. In today's video, we're going to learn about object-oriented programming. And if you are with me the whole time since from the beginning of this series and to this point, well, congratulations, because I'm going to tell you that this is you started to get into the advanced level of programming, because what you have learned so far, those are the fundamentals that you need to know to create any kind of program. But this one is going to give you the advanced level of programmers, and learning object-oriented programming is going to give you a superpower so that you can able to learn other frameworks and understand how they work way more better. So in this video, you're going to learn what is OOP and how to implement it in your program. So what is object-oriented programming? Well, object-oriented programming is just a way of programming that's going to help you to take everything from real world and convert it into code, or I said convert it into a create the virtual version of that. Assuming your smartphone in physical world, you can create a virtual one inside a computer by the help of object-oriented programming. Look at your laptop, you can create the virtual one inside your program. Look at your TV, game, and whatsoever, everything that you can see in a real world, you can create the virtual of that thing, or we call it object. Any object you can see. So this is what object-oriented programming come into play. It's going to help you modernize everything from real world into programming. So how can you be able to do that in programming? Well, don't think it's magical that you can just convert everything into programming and just start working on it. No, it's not like that. It's like creating the blueprint or the concept of how that thing works and make a computer mimic that behavior using object-oriented programming. So let's see an example of let's use a doc as an example to create an object of a doc. In object-oriented programming, there is two things you need to know. There is something what we call properties, that this properties is the thing that describe the object. For example, like color, size, power, and so on. And then we have behavior. Behavior, this is what we call like the action it takes. If you look at a dog is back, he's run, maybe he run 2 miles per hour, 1 mile per hour, or something like that. That's his behavior. And then his properties is like dog is black and he has a lot of hair and so on. So also you're going to implement all those things in object-oriented programming. And then we have four main principles of object-oriented programming, which is we have encapsulation, abstraction, inheritance, and polymorphism. You're going to understand all of those principles in our example. So now let's see how we're going to create a class of dog, and so that you understand the object-oriented programming in a better way. So for us to orient a dog into our program, or to create a virtual version of dog into our program, first of all, we're going to start by calling a method, a keyword called class. Then when we write this class, now Python programming think that since we put this class, is going to say, okay, this programmer is going to create an object. So what object is he going to create? Then we're going to put the name of our object. In this case, our name of the object is dog, and then we put colon. So now since we put the keyword class and the name of our object, then we're going to start implementing its properties. So we can start by implementing its properties. For example, the dog, which color is the dog? Is it black? What is the name of the dog? And so on and so forth. So for us to implement the properties, we're going to say, okay, define, and then double underscore. This kind of method we call it dunder method, or to double underscore method, and then we say init. So you see, this is, if you can remember in your previous class, this define, we usually use it to create a function. So it's the same thing in programming. in object-oriented programming, we use def to create a function inside a class, and that function is not going to call function but is going to call method. So I hope you understand. So this define init method, this method, initial method, is the method that's going to assign our properties to the object. For example, we want our dog to be black. Then we're going to say, okay, self. This self indicate that we are referring back to our dog object, which is this dog is what we call this here self. That's what we pass as our parameter. So then we're going to say self dot color. That means the color of our dog is black. That means it is property. So remember, whatever we implement inside this dunder init method, it is the property of the dog. What the dog going to do, and sorry, what the dog is going to be look like in its properties. Then self.color, which is dog.color, is black, and then we're going to say whenever I call this self, I referring to my dog class. Okay, then we say self dot name, which is the name of our dog. Then let's call it Matt. So now we have our dog has two properties, color black and name Matt. So now we implement the property of a dog. So what is the action of our dog? What is dog is doing? Is it run? That the action it takes, like his behavior. So to implement his behavior is easy. It's also going to write this def keyword, and then we call the name of that action. So let's say like vac. Then our dog is totally going to be back. Then we're going to, after we call this method back, then we're going to pass our dog as a parameter, which is self, and then we're going to put colon. Then we're going to implement what is the action is going to do when this back is called. Then we're going to say it's going to just print dog says woof. So now we implement one of its method, and also we're going to implement another method like run. Then we pass our dog colon, and then we set print our dog run 3 meters per minute, or let's say per second. Let's leave it like that, 3 meters per second. And then now let's save it. So this is what we call a class. Class is like a blueprint, like a map that show, okay, whenever we create an object of this dog, this is how the dog going to be look like. So now let's create an object, which is the object is going to use the class. That class define the object. So let's call our object, which is dog1, and then dog1 is going to be dog. So this is what we call the instance, or I said the object of this class, which is dog1 is the object of dog. This dog is the definition of how this dog object going to work. So let's see an example. We're going to say dog1 dot bark. If we say dog1 dot bark and we run it, so whatever we have inside this method bark is going to be executed. If we run it, you see dog say whoop. I hope you understand. And let's call another method, which is dog1 dot run, and then if we say doc1 dot run and then we run it, we're going to see something like this: doc run 3 meter per second, something like that. It's exactly what we executed inside this define method, which is run keyword run method. So we have this define in it, which is we use it to implement the properties of our object, which is doc, and then we use this def back and run to implement its behavior. And by calling this behavior, it's like we ask our object, which is doc1, to make the action. So now if we set doc1 dot name, we're going to see the name of the object, but I have to print it. If I said print doc1 dot back, sorry, I said back, I mean name. Yes, because that's one of its properties. If we say doc1 dot name, then we're going to say call math, because this is all what we implemented inside our class, which is the blueprint of how this doc object going to work. So but let's assume that instead of giving it a name, since from its properties, let's allow the person that using the object to pass the name. Then we're going to say name, one of our parameter, and then we set color also as our parameter. Then we're going to see what he passed through this parameter color. That's what is going to be our properties. For example, now I said doc1 equals to doc, then I have to pass those two parameters that I put here. So I have to put the name first, which is, let me call it let's call it John, and then the color we're going to say red, something like that. So this doc1, if we say doc1 dot name, then we're going to see John. Doc1 dot back, then let's say let's put the name instead of doc say whoop, let's say John say woof, and then we're going to just say self. We have to call our object, which is self, then we call the properties, which is name, self dot name, and then let's put it here also. See, so now if we run it, you're going to see the differences. Here I put John and red, so I created the instance of this object, and this doc1, whatever I call its name, then I'm going to see exactly what I put here. When I call it is color, then I'm going to see something like this. If I copy this and call it again dot color, then I'm going to see the color I put, which is red. So let me run it. So you see I have the name, which is John, color red, and then back John say wolf, and then I say doc1 dot run, which is John run 3 meter per second. So this is how you're going to implement object-oriented programming in a simple way. So all this, if we ignore all how we implement this class, and we just focus on calling the object and executing this is what we call abstraction. Abstraction is just like we don't know exactly how this doc is being implemented because we don't see, but we just call it and use it the way we want. So since we understand how this doc works, but we don't know exactly how it works behind the scenes, so this is what we call abstraction, which is all how this doc class, how it's implemented, is being hidden from us. So it's called abstraction, object-oriented programming class. So in our previous class, we discussed about what is property, behavior, and I said in this class we're going to continue by discussing about private behavior and private property, and also we're going to discuss about the remaining three concepts of object-oriented programming, which is encapsulation, inheritance, polymorphism. So let's start with encapsulation. Let's assume there is some behavior that our dog has, a property that our dog has, but that property is private. We can only know that property if we talk with the owner of that dog. For example, let's say the age of the dog. Not everyone going to see the age of the dog in the dog body. You can't look at the dog and say the age of this dog is 20, 10, 5 or whatsoever. You have to ask the owner of the dog before you can know what the age of that dog. So that kind of behavior, that kind of properties, you call them private properties. So we can also implement that kind of private property in our object-oriented program. So how are we going to do that? If we're going to implement a private property, we're going to call the self, which is the dog instance. That's this dog, that's what we call here the self. And then when we call the self, then we're going to put underscore, double underscore. When we put this double underscore, then we're going to say age, then is equal to, let's leave it as, let's say 10. So we can't access that properties. I can't just say doc1.age or doc1.double underscore age. We can't access that. So if we're trying to access that, let's see what is going to happen. Say doc1 double underscore then age. So let's see what is going to happen. We access a private property. So you see, it says attribute error. Doc object has no attribute double underscore age. The reason why it said it doesn't have it, we do have it, but it make it private so that a public person can't access it. We can only access it within the class or within the blueprint of this, within the class of this doc. I can access it within this one of those methods. For example, I can do something like that. If I like, I can just say print. When we call this back, or let's create another behavior called your age. Let's call the behavior your age, and then this behavior is going to print out the name of that dog. Like, is the dog is going to talk and say my age is so. So we're going to print it out, print, then self dot double underscore age. So the reason we can access this, okay, let me put some word that's going to say my age is, then we're going to see the output. So now if we run it and we call this behavior call doc1.yourAge, then we're going to see is print the actual age, even though we have it as a private, but it's going to print it out. So if we scroll up, we see say my age is 10, because we can only access this double underscore method, this private property within the class, but we can access it from the object itself. So now we understand a private property. Let's see how we're going to also create a private object. So also private behavior. A private behavior is the same thing with how we implement a private. We're just going to put double underscore, and that make it a private method, or I say private behavior. If we run it now, also going to say doc1 doesn't have attribute your age because we make it private. But if we call it inside one of our method, for example like run, and I just say self dot underscore your age, So we can be able to call it inside one of our public method, but we can't access it directly. So now if I call run, I'm going to see something like this, which is say my age is 10 and then John run 3 meters per second. So you see, we can be able to access it in one of our methods, in one of our public method, because we include it here as a private from the instance from the class level, and then from the object level we access the one that is accessible, which is this run. And then when this run is executed, then it includes this private one. So that's how we're going to work with this is how you're going to create a private behavior as a private method. So I hope you understand how you create a private property, and also how you create private method or behavior. So now let's move on. This private behavior, or I said private property or private behavior, is what we call encapsulation. Encapsulation, that means we encapsulate it. The person that just working with this instance, which is the doc class, and created this doc1 object, he will never know that we have this private properties inside our doc, unless he go and look out the code. If he doesn't look at the code, let's close this code. So if he just code it like this, he will never know that we have those properties, because they can't be accessible from the object itself. It only be accessible from within the class. So that's what we call encapsulation. What about inheritance? So let's say you have you're going to create another doc, but maybe a different kind of doc, but it's also a doc. Let's call it a 4p. So we're going to create our class the same thing the way we do it. Say class, and then we call it 4p, and then the 4p class is going to inherit from its parent class, which is doc. Say doc, and then put this. So now, since it's inherited some of his behavior from the doc parent class, we can modify that we can modify the properties of the parent doc. For example, in our doc, we have color, we have name, and also we have age, which is private, which is we leave it as 10. So but if we want in our child class, which is this 4p that inherited from this, we're going to set okay, define double underscore init. Then as you can see, it's already implemented. By when you call this init, then we're going to accept the name and also the color, and also let me add another thing, which is size. So you see, in our parent class we don't include size, we only have name and color. But in our child class we also include a size property. So this init method, there is something that I did not tell you in our first tutorial. The moment we assign this doc class to an object, this init method is going to run automatically. It's like the moment you open the door, then the light is going to light up. When you close the door, then the light is going to off. When you open, the light is on. When you close, the light is off. So this is exactly what this define init method is. The moment we call this doc class, then it's automatically run and assign all these objects that we put here as parameter and assign them. I hope you understand. So then so now I'm going to also call self.size, then is equal to size. That means what we pass from here. So what we pass from here is going to be stored at self.size. And when we call this name, we also know how we going to implement this self.color, self.name, and so on. So this is what we call inheritance. That means we inherit from our parent dog. So all those methods that we can call from our parent, which is, we can say dot back, dot run, and that's all the public method we can access. So if we run it from the puppy class, it's also going to be executed based on the puppy, because we already inherit them from our parent class. And also we can add our own class, which is what's your size, and then we say self, then define what's your size. Then let me just say print, then the puppy will just say self dot size. So this method, what's your size, we add it into our puppy class. We can't access it from our parent class, because our parent class, which is dog, doesn't have this method called what's your size. But in our puppy class we can access it, and also we can access other methods from our parent class. So let's create our puppy. Let's call it puppy, and puppy is equal to puppy class. We pass it the name, call it pop, that's the name. Then we pass the color, let's call it brown. And then the size, let's call it, let's say 3 meters square. Okay, let's leave it like 4 feet. Let's assume that's the size of our 4 feet. So you see, now if I set, let me delete this, which is the parent one. Let me call puppy dot back. So let's see what is going to happen. We see in our puppy class, I did not define this method called back. I already have it in my parent class, which is the dog, this dog class that we inherit from it. So now if we run it, let's see what's going to be the output. So you see, pop say woof. This is exactly what we wrote in our parent class. And also I can say puppy dot what's your size, the method we created specifically for the fourth. You see, 4 feet. So this is what I just want you to understand. This is what we call inheritance. We see what we call encapsulation by creating those private stuff, and then inheritance, which is inherit from our parent class. But there is one thing also. Let me call that back. Let me call the back method that we have already in our parent class. See? So, but in this case, I'm going to change how it works. I'm just going to say print instead of puppy say woof, is going to say yip yip. Let's say yip. So pop say yip yip. If we call our parent class, which is dog, we're going to see whoop. But in our puppy class is going to be yip. The reason is that we override the method, which is we change it. This is not what we put in our parent class, but in our child's class now we override this method called back method. So this overriding, that's what we call polymorphism. They are the same method but work differently in an object. So if you run it, you see pop say yip, whip. But let me create the parent one, which is since we created the dog one dot, let's call the back. We're going to see the parent say wolf. See John say wolf, but since we override in our child class, now say pop say whip whip, so something like this. So this is what we call polymorphism. We have the same method but work differently in a different object, but they are the same class but they are work differently because we override this one. That's polymorphism. So now we understand all the concept of object-oriented programming, which is we understand what is encapsulation, inheritance, polymorphism, and abstraction. So if you enjoyed this tutorial, please subscribe to this channel. Then let's create a project. In our next class, we're going to create a small project. There is a lot of things you need to know in object-oriented programming, but if you understand those things, those three concepts, property and behavior, and then the four concepts of object-oriented programming, encapsulation, and so on, you already understand it. But there is other things that you have to understand, like meta class and other stuff related to object-oriented programming. So let's see you in our next class.